My name is Mehdi Ramati. I'm working in Norway as account manager, and I have the responsibility for this webinar with Wasim as my colleague in UK. It's many people, attendees at this webinar from different countries. So everything will be recorded, and it will be sent out to those who couldn't attend to this meeting. And we will follow you up later on regarding calling you up and see and help you further with the solutions and with the products, so we can go deeper into the material if you want that. So everybody will be called up later during this week or next week. We are going through I'm going to go through some topics. We're going through Autodesk Inventor Stress analysis. We are going through Autodesk Frame analysis. We are going through Autodesk Inventor Nastran. And we are going through Altair with some SimSolid. SimSolid is for a little bit. It is ideal for a little bit more complex models and drawings, but Wasim will go through that with everybody. I will be the sales rep in every country, but most of it, of course, in Norway. But you can grab hold of me or grab hold of your salesperson in those countries you are in. If any questions, please use the chat for questions, and we will answer them as soon as possible. Then I give the word to Wasim. Please, Wasim.
Thank you, Mehdi, for the introduction. Welcome, everybody. We do appreciate your time this morning. I just wanted to go through a small amount of formalities. We have a lot of attendees in this webinar, so if you can just post your questions in the questions columns, and we will try to attempt to answer some of them, if not all, but we will answer them after the webinar if we do not have time during the webinar. There is also a PDF document of this presentation in the handout section, which you can download during the webinar. It's basically a copy of all the slides and the hyperlinks, which I will introduce you to the products to access further information. Just a little bit about me before we begin, as I recognize there's many people on here which probably not familiar with me or my okay. So we have been working for Symmetry for almost over 10 years, and I've have a fair amount of experience with different types of simulation tools within the simulation industry. The agenda basically is going through the technologies which Mehdi sort of represented and talked about. This is primarily Inventor Stress analysis, frame analysis, and Nastran. And also we're going to mention something about Altair SimSolid, because we are finding that the product is ideal for many large complex models. So I'm going to try my best to do some live presentations so you can see and have a look and feel about the products. And then I have some information which you can download from the handout, from the PDF, which you can download in the handout section. It's got hyperlinks if you need to access more information about the products. And just before I carry on, everybody can see my screen and can also hear me loud and clear. Yes. So basically, just a brief introduction. I understand that some of you may not be using simulation. So the idea behind simulation is that is to validate designs earlier, be able to cut costs due to failures in service, and optimize material cost, and most importantly, to design with confidence so that we can actually design for if it's going to be fail, what happens if it drops, and how long or how strong does it need to be. Basically, a lot of what if scenarios. And simulation can help us to reduce design and development costs, avoid failures in service. I don't think anybody wants to sit in the plane and see that happening to the engine through the window. Be able to innovate, and most importantly, be able to sort of design with confidence, or be able to make more informed design decisions. Now, at the moment, many of you will have access to product design and manufacturing collections, which includes Inventor Stress, frame analysis, and Nastran. And then there's an alternative tool called Altair SimSolid, which is designed for large-scale models or complex geometries. I will show you an example of where it might be appropriate in your sort of, and you can relate to that one. Okay, so let's start with Inventor Stress, and I think many of you here are familiar with this technology. Inventor Stress is primarily linear analysis and modal analysis. And in terms of element types, now a little bit technical, it does solids and shells. It basically allows you to do single part analysis and assembly analysis. Frame analysis, which is probably not very popular with many customers, is that it's basically it's called frame analysis, but it is structural analysis software. In that is for building structural frameworks. If you're familiar with Frame Generator or Content Center, it is ideally designed for that type of thing. You can see here's a platform, and it's basically beam analysis is the other word used in this type of analysis. And you can see here it only does beams. Then you have access to Nastran, Inventor Frame and Inventor Stress. You can see that straight away inside the Inventor environment because it's part of the standard installation. Inventor Nastran, on the other hand, you will not see that. It's a separate install, but you do have access to it as part of your collections. And it is a very comprehensive software which allows you to do buckling, fatigue, nonlinear, and many more. The list is too large to sort of fit in the space in here, but I will show you what it can do. It is very comprehensive, and it allows you to do solid shells and beams examples, and I will go through one of the examples. So the way I've designed this is I will show you examples which can only be done in each of these different technologies. And the examples which I'm going to demonstrate in the next couple of minutes, hopefully try to keep the timing as well, is in stress analysis, we're going to look at the little lever example. In the frame analysis example, we're going to look at a platform. And in Inventor Nastran, we're going to look at a plastic bottle with, you can see the stiffening rings around it. So let's just go straight into the environment. Okay. So just 1 minute when we can see Inventor. There we go. Okay, so we're in the Inventor environment. And what you can see here, we have a simple assembly, a lever and 2 pins, and you can see it's a half a model. So we can go into the stress analysis environment. You can see here you have stress analysis, dynamics, frame analysis, and also Inventor Nastran once you have installed it. So once we go to the stress analysis environment, okay, what you see straight away is an example which has already been completed. So I'm just going to go to the one which has got no setup. So everything you require in Inventor Stress is basically at the top. There is no extra buttons. It's what you see is what you get. The materials do come across. If I go to assign, you can see the materials have come across from inside the Inventor environment, so you don't need to redefine them. And so the only thing we need to do here is we need to simply apply the constraint. So I'm simply going to fix the pins at this side here. Because we are doing a half a model, it's very common in the FEA world. We will simply use frictionless constraints to define symmetry. Okay. And the next task would be to apply a load to exert some stress into the geometry. So you have force, pressure, and you've got all these tools. So if I bring this to this dialog box here, so let's assume we're going to pull it in the X direction. Let's put a load first of all. Let's try a bearing load. And let's put, okay, doesn't like that. So we'll go from here. There you go. So now it's almost ready. The only thing we need to do here is if I click on the mesh view here, this will generate a default mesh. And what you have inside, okay, it's not very good. So you can go into the settings, mesh settings, and you can start altering the mesh values to get a mesh which you're happy with or is a reasonable mesh to start with. So I've changed that. Let's see what the mesh looks like now. Okay, that mesh looks decent. So in terms of time, which you've lost in the webinar keep crashing, I'm simply going to go to the one which I've already done. And we can get, these are the type of results you can get. The one thing I did not show you here is it's created contacts. Now these contacts are bonded by default, but you can very easily change the contacts to, let's change that one and that one to, so these are all the different type of contacts you have available inside Inventor Stress. So that's the one we're going to use. And the other two, we can suppress them because I don't think they're going to make any difference. So you have the ability to modify, suppress, and change contacts to simulate reality. So I'll suppress that one. And then we'll go back in here again. And you can see here, if you want to do different load cases, different materials, you can copy these simulations. And the results tabs you get in there are one misers. You have your first principles, your compressive stresses and displacements. And then you also have stress in the X, Y, and Z directions and your shear stresses. And you can create a very, very basic report. So it is very good in terms of what it does. It's ideal for smaller components where you have assemblies, bonded and single parts or assemblies. But when you start getting into more complex assemblies, then it's probably not ideal. So let's have a look at something completely different. What we got here is a frame or a platform, and every single tube in here is modeled using the content center, and which is not a tube, is modeled using the CAD modeling environment. So what we can do here is we want to find out if the platform is strong enough to carry people and their weight. So we've got frame analysis. You can access it from there, and I think you can access it from here as well. So it doesn't matter where you access it from. So let's go into frame analysis. Frame analysis is only accessible from within the assembly environment. So when we create simulation, it gives us a choice whether it's static or modal analysis. So I'm going to click on static. And what will happen is it will convert every single tube into a line. And there we go. So every single green line there is now being idealized. So how do I know that? If you go into here, if I right-hand click on properties, there are your cross-sectional profile properties of that beam. So what we can do here is the same thing. So first of all, let's assign the gravity in the correct direction. Okay, it's in the wrong orientation. Let's go in the X, downwards. And the next thing we can do here is put the brakes on the wheels, and we can start putting constraints on these things. So let's pick one here. And let's display what's happening. There's the first one. So I'm picking the end of the lines just to simulate the wheels are on brakes. Just got two more to go. There we go. And the next thing we need to do here is to apply a load. So we're going to use a continuous load, and we're going to use the default values, and we can pick on the beams as we go along. Okay, and the last one. So now we have the constraints and the loads applied, and the only thing left now is to press simulate. And frame analysis is pretty cool for what it does. It's very simple user sort of workflows in here. Now what I'm going to do here to make things a little bit simpler here is I'm going to hide the 3D objects, and you can do that in here. In here, invisible, and one more thing I'm going to do here. Okay, there we go. So we can see the colors. I'm going to hide the boundary conditions. Right, so what we can do here, once you've done the results, we can look at beam details. So this is what typically is required in a beam analysis. I'm going to pick that beam there, and you can see here it gives me all the shear forces, bending moment diagrams, and all the information you typically need. And you can also do this. If I pick that beam there and pick this one here, you can plot the bending moment diagrams on the actual 3D model itself. Obviously, there is a lot more in here, so I just want to give you a quick overview of what is happening. So that simply shows you what is possible with beam analysis. Now we'll quickly move into Nastran. In Nastran, what you see here is a surface model and line representing beam elements. What you can do in here, so when I go into here, something like this cannot be achieved in Inventor. The reason why we do shells is because it's a lot simpler and it's quicker to analyze. So what you can do in here is, obviously the user interface is a little bit more comprehensive than the stress analysis environment. And what you can do here is you can specify different types of idealization shells for thin structures. We have ABS. We can specify 3 millimeters for thickness, and we can simply just draw a window around that, and we'll pick everything up. And then we can then start defining the beam idealizations for the stiffness, the tubes going around the plastic. So if I go to line elements, cross section, so you can do these type of things in here. You can specify any type of profiles. I'm going to go to the tube, let's say 20, and let's make that 8. These are the radiuses. And then you can simply, first of all, change to aluminium. I'm just going to draw a window around such like that, and pick this one, this one, this one, and finally this one here. And then we're just going to do the legs now with different profile. This is showing you, so this one's going to be a bigger diameter, so let's just try 20 and 18. And again, we're going to pick these lines here. And now we can generate the mesh. And this is what I like about it. Now, obviously, you want to see how big the profiles were in comparison to the geometry. And you can simply look at the cross section. There you go. It's not very pretty, but it gives you a 3D sort of a representation of what the thing looks like. Once you've done all that, you can unhide the 3D view. This object basically is full of water, obviously. So one of the things you can do inside Nastran, you can apply hydrostatic loading. So the point on the liquid the point there is 0. So if I'm going here and specify the liquid is a meter high from that point, and the fluid direction is going to be in the -y directions, as you can see from the cursor here. And finally, we're going to specify the surfaces which will be exerted by the load of the liquid, the water. It's these here. And it's going the wrong way. So we can change the pressure direction here. And sometime today, there we go. If I want to look from the inside, you can see the arrows are pointing outwards, just about. And so obviously, and now we're ready to run. So I'm simply gonna, okay, so we'll go back to the one I've done already. The only thing I've not done here, I've not fixed the bottom of the legs, but you'll see in the one I've done already, it's basically constrained at the bottom. There you can see it. So let's have the loads, and it's basically very similar to Inventor Stress. You can look at the stress results, displacement results. There we go, and then you can do some clever, there's a section view in here already. Just let me get a view which everybody can see. Upside down. There you go. So one of the things you can do inside Inventor Nastran, you can do section views. So now we can see the stresses inside the model. Okay, so I hope that's just a quick overview of what the different softwares do. We are hoping to do these more webinars on the particular solutions, so we can spend more time and talking more about what the software can do. And now I just want to go back to now. So the one thing common with all these technologies is that everything requires a mesh. Now, this is more like traditional softwares. And just to make sure the mesh doesn't have any issues, we have to do some sort of simplification. That could be removing features, or it could be modding, editing models, or remodeling the whole thing again. And these are the typical features or issues which you may come across when we are trying to do meshing. Obviously, this extreme geometric, which is lattice structures, is impossible to do with Nastran. We model things which are big and small. We have gaps and overlaps, this type of thing. And basically, these are all issues for the mesh which needs to be cleaned. Now, what we found 2 years ago, we looked at a product called SimSolid. Now, this software does not require any meshing. It does not require any simplifications. You simply do your CAD models. It can be as complex as you want it to be, and it simply works. And all the issues you have with the mesh are non-existent with Altair. Now, what we found is these are the 4 areas where SimSolid is absolutely brilliant, or has a place alongside Nastran. Complex models. Nowadays, more and more companies are looking into 3D modeling, lattice structures. We have companies who are making big structures, platforms, buildings, and also we have customers who have feature detailed models with bolts, washers, chamfers, everything in there, and they want to not do any simplification, and the software runs very, very fast. It's not on the cloud, it's on the PC. And the example I'm going to show you here is a customer who had been using Inventor Stress and Nastran, had issues because the models are pretty complex. They are thin and large, and they were our first customer who actually then took on Altair SimSolid. And then they've been kind enough to sort of share their example, which I'm going to demonstrate to you, and you can see the speed of it. So let's just bring it back. So this is a model, and you can see when we design things, we have everything in there. We've got the text there, we've got plates, everything. Now, this model has not been cleaned up. It's come straight into SimSolid. And what we're going to do here is we're simply going to use SimSolid to remove these small items. So you can see here, these are all the components which have come across. Let's make that window a little bit bigger. And if I look at the magnifying glass, you can see here, these are the text being. So I'm simply going to go back and remove. You can suppress them or you can delete them. It's entirely up to you. In this case here, these are the items I'm simply going to suppress. Okay, we're going to leave that one. And you can see here, materials have already been predefined. The connections, just like Inventor Stress, you can simply click on the automatic button. These are the default tolerances. If there's anything with a bigger gap than 1, it will not pick it up. So let's just try this and see what happens. Do apologize for the time. We are running over time, so I do apologize. So now you can see here it's got 3 disconnected bodies. So that basically means something's not connected. Well, that's all connected. These pieces are not connected. It simply means that I have 2 choices. I can simply either increase the tolerance, or I can do something unique in here, and that is I can create some welds. So we'll go into here. Let's specify a weld size of 10, perhaps. Let's pick that component, and let's see if we can connect these with the weld. So we can find the welds between them. We keep that, we'll delete that one. It creates welds inside and outside, so we'll delete the ones on the inside. We'll keep that one and delete that one. And there you see it's created a weld. Now we can do the same thing on the other side. Okay, that's the master. We'll delete that one and that one. Okay, now there is something here. This is a folded plate, which means there's a gap in there. So you would have to fill that gap up, because you can't create a contact between its own part. But that's what I'm going to show you here. I'm going to create a contact. Let's do it from here. I just put a weld in there. Okay, let's pick that piece there. And yes, we'll make the weld a bit smaller than that. And again, it creates, there you go. We want to delete the inside one. And if I zoom in, you can see it's created a weld there as well. And then we're just going to do one more. And let's make this one maybe 6 and show you a different method. One here. And let's say one here. Okay, so now we've got all the welds. And what I'm going to do here is I'm going to check if there's anything which is not connected. We have nothing connected. Now, the good thing about SimSolid is it allows you to create welds, unlike our Nastran, which you can't create welds. You have to create the welds inside a weldment assembly. So we can perform structural linear analysis in here. So I'm simply going to fix this face here and this face here. And I need to apply the load on the top half of the drum. Now, I don't want to do a split face, which we need to do inside Inventor, Nastran, or stress analysis. This is what I like about the software, is we're going to do this, which is pretty unique. I'm simply going to create an area when I want to apply the load on it. So what we'll do here is 1000, 1, 2. Okay, that's the area we're going to apply the load onto. In the minus y directions, let's put 75,000. And look, you would have to split the face. So once we've done all this, I think we're ready to run. Now, watch. So what the software is doing is not running one analysis, it's running 3 analyses. It's converging the results as it goes, and see how fast it's doing it. Something like this inside Nastran stress analysis, you'll still be setting it up and trying to get it to mesh. Now that's finished. So you could look at the displacement results, stress results. You can change the scale there. Let's make it 50 or even 20. And you can see the maximum stresses on the welds. Okay, and then the other thing you can do here very easily is you can look at reaction forces on your constraints. There's one here, one on the opposite side. Not just the constraints, it's very, very easy to look at reactions on your contacts, even on the welds. And it gives you a list of all that. There is a lot in there, everybody, so I just want to give you a quick preview of what SimSolid is capable of doing. And because of time, we just want to go through further information of how we can help. Okay, Oop, there we go. So I've got some hyperlinks in here. You have the handout in the web meeting, and you have information on Nastran. You can also look at I did a presentation in a bit more detail on Inventor Stress and Frame Nastran. You can have a look at. And also you've got a blog post. Let's look at this one here. So basically, if some of you have access to a Nastran already, you can click on that link and there should be some guidance on here. Look, there is simulation for designers. So there's got a 7-part series in here, giving you some tips and guidance based on best practices. And one more here, which we can go through. Let's see, where's it gone? And if you are interested in learning a little bit more about it, you can actually click on the links. Oops, didn't want to do that one. Just trying to click on the link. Maybe it's not live. Basically, if you go on the websites, we are scheduling these courses on a regular basis. And finally, if you're in the oil and gas industry, we have a webinar, I think next week, which is more detailed about Altair and SimSolid. And it'll give you a workflow being done by a company called Technip FMC, which are a big company within the oil and gas, and they are doing large scale models. So we would sort of suggest, if you are doing large scale models, to have a look at this webinar. Now, and obviously with the questions, let's have a look if there's any questions here. Okay, I have a question here, and the question is, does the beam analysis not require the use of frame generator? If you are doing beam analysis inside Inventor Stress, or well, frame analysis, unfortunately, you will need to use frame generator. If you don't use frame generator, then I would suggest to do beam analysis inside Nastran, which does not require a frame generator. I hope that answers your question. Let's have a look at some more. Okay, can you do non-linear analysis, elastic plastic? Yes, you can do that inside Nastran, and you can also do it inside Altair SimSolid as well. And one more question, buckling analysis. Yes, you can do that buckling analysis inside Nastran, but not inside Inventor Stress. There's a lot of questions, everybody here. So what we will try to attempt to do is basically answer the questions and get back to you. We are planning to get back to you. In each country, there is a very short survey. As soon as we finish the webinar, I would appreciate if you could spend 1 minute. It will just take more than about 30 seconds to fill it in. It will give us some information on how we can best help you guys. And finally, thank you very much for your attendance. If you have any questions, you can get in touch with us. Thank you again, guys. Bye for now.